So in our last session, we understood about the pin diagram of Arduino Uno.
सर मेरी प्रॉब्लम का भी कोई सॉल्यूशन निकला?
सोल्यूशन आपकी प्रॉब्लम का मैं निकालूंगा तब ना, जब आप मुझे कांटेक्ट करोगे। आपसे मैंने बोला था क्लास के बाद हम करेंगे, आप क्लास में ही नहीं आए।
सर परसों ही तो नहीं आया था सर।
तो मैं तो तभी
कल
सोल्यूशन
तो आया था।
निकालूंगा ना। कल आप क्लास में थे।
सर आज निकाल देना सॉल्यूशन। कोई नहीं। ओके सर।
ठीक है, ठीक है। आप इस बार इसके बाद स्क्रीन शेयर के लिए रिक्वेस्ट कर देना, मैं देख लूंगा आपकी जो भी प्रॉब्लम है। Okay, so in our last session, we understood about the pin diagram of Arduino Uno. Now we are going to start with the programming part of this. So for that, let's uh, first drop the Arduino Uno to Proteus screen. And here we have pins starting from 0 to 13. That means total 14 digital input output pins. So what I'm doing, I'm going to connect one LED with it as we did in the AVR controller. So let's connect one LED yellow color with pin number 13. We have two terminals of this LED. So let's connect the positive terminal with the pin number 13 and the ground one with negative terminal of your LED. So if we give the logic 1 through pin 13, LEDs will work, and if we give the logic 0 through pin number 13, the LED won't work. Correct? So now let's try to understand about the program. So it's same like C programming, and we already understood about the concepts of AVR programming. So it will be very easier for us to understand how we program in Arduino Uno. And it's not only about Uno. You can even program with the same concept on Mega, Nano, Pro Mini, or any other controller of Arduino board. And in the same way, we understood about the programming of Atmega 16. So you can write the programs for Atmega 32, Atmega 8, Atmega 2560, or Atmega 1280 by yourself. Even in one example, we took another controller of AVR and connected few components with it and checked the same program. So now when we start with the Arduino programming, first of all, we need the software which is called Arduino IDE. IDE means Integrated Development Environment. So by default, whenever we create a new file, it has two loops. The one is called void setup and another one is called void loop. So if you have to run your process for infinity period of time, you have to put that in void loop. And if we have to run any process for only one time, we have to put the main code in setup. So let's say we have a LED which we want to turn it on or turn it off only for once. So we have to put that code into setup part. But as we are not going to do the process for infinity period of time, that does not mean that we will we will delete the void loop. In the same way, now suppose if we have to run the LED on and off for infinity period of time or repeatedly, we have to put this code in void loop, but that does not mean that we will delete void setup part. So whether it's empty, this is the part of your syntax, you have to keep this during programming. Next, we have data types like int, long, char, string. Int for integer, long for lengthy values, float for decimal values, char for characters, and string for set of characters like A, B, C, D. Then we have operators again, relational operators like less, greater, less equal, greater equal. Logical operators like and or not. Symbol we have to use for these things. And then arithmetic operators like plus, minus, multiply, divide. So these are same as all other programmings. Next, we have a predefined command for DDR. Like the DDR command was to define the port as output or input in AVR. So here we have same concept but with a different command, which is pin mode. Pin mode. So in pin mode, we can define the direction of the pin. Whenever we work on AVR, we define the whole port, like port A, port B, port C, or port D. Whether you use one pin of the port or all the pins of the port, but we have to program the whole port at the same time. But when we talk about this Arduino IDE or Arduino programming, that time we have to define the pins individually. That is why it is pin mode. That is why it is pin mode. And in pin mode, we have to say variable, comma, either output or input. There it was 1 or 0, but here it is simply we need to write whatever we are going to define. If it's output, we will define output, and if it's input, we will define input. Then next, we had one register which was port register, port X register, port A, port B, port C, port D equals to 0B, then 1111, 1111, or 0000, or 0000. That means either we are writing the 5-volt supply to all the pins of that port, or otherwise we are writing the 0-volt supply to all the pins of your port. Here we have command for that called digital write variable, comma, high or low. So high we write for 5-volt, that means logic 1, and low we write for 0-volt, that means logic 0. So whenever I am writing these two commands like pin mode, we can see the M is capital here without any space, and for digital write, the W is capital without any space. And in case of output and input, it must be capital. In case of high low, it also must be capital. Then next we have a delay function like underscore delay underscore ms braces value. So here we have a delay function in this way, delay, and then define the value of your delay. And unit for this is again same, which is milliseconds. And to comment, we have double slash here. Then if we want to read the data, there we use the masking process. There we use the masking, and then we started comparing it inside the if loop. So here, if we have to read the data from any pin, we have a simple command called digital read, and whatever we want to read from a variable or a pin, whatever we want to read from a variable or a pin. In case of digital write, we need to write either high or low, but in case of digital read, we cannot say that it's high or low because we do not know what the sensor or what the button is giving us. It might be high, it might be low. So we do not know about that thing. That's why we are saying simply read it, read the variable. Then we have a lot of other commands as well, but whenever we will be doing those commands, that time we will try to understand. For now, these 4 commands are enough to start. So here we have connected one LED at pin number 13, and the positive of LED is connected with 13, the negative of LED is connected with ground. That means if we give logic 1 from pin number 13, LED is going to turn on, and if we give the logic 0 from pin number 13, the LED does not glow. So let's start writing the code for this. So I already have this Arduino IDE, and I told you yesterday how to install this package. And even earlier also I explained about these things. So now I am writing int LED equals to 13. Int LED equals to 13. That means LED is a variable and the data type is integer, which we are initializing with the value 13. Why I am writing 13? Because we have connected it to 13. But this line does not mean that we are saying LED is connected to 13. No. This line simply means LED is a variable and the data type for that is integer and the initial value for that is 13. Now, when we say pin mode, the command is variable, comma, output or input. The command is pin mode, variable, comma, output or input. So here the variable is LED and the mode of this pin is output. So simply we have to say pin mode LED, comma, output, and let's put semicolon to terminate the line. After this, if we have to turn on this LED, we can simply write digital write. Again, it's variable, comma, high, low, So this way, currently we want to turn on the LED. So we are saying variable is your LED. So let's replace the LED with variable. And then one sec. LED comma, and then it's high. If we want to turn it on, simply we have to say high. Now let's save the code. So I'm saying saving this code in the same folder where we save the code of AVR. It's batch 10 p.m. 21st June. And let's write P1 is already there. So I'll be writing PA1, program Arduino 1. And now let's go to Sketch and compile the code. So in Sketch, we have an option export compiled binary. Export compiled binary. So we have the same method to build the project. Here we are writing the code in embedded C language, and when we wrote the code in your ITML Studio, that was also the embedded C language, but extension was, but that time the extension was .c. But this time it's not C, it's .ino. So .ino is basically the format. .ino is basically the format to write the code in Arduino IDE. Now, using the compiler, we are going to convert the code from human understandable language to machine understandable language. And the machine understandable language is basically your binary language or hexadecimal language. That means we are converting this code into .hex using the compiler. So what we just did, we converted the code using the compiler, and now the .ino language is converted to .hex, hexadecimal, right? So next, what we need to do, we have this Proteus. Simply, let's double click how we did earlier. Let's double click how we did earlier, and let's go to program files and let's browse it. Let's go to the same location, batch 10 p.m. 21st June, and here we have the folder PA1, and the file is with the name pa1.ino.standard.hex. So let's select the file and click OK. Now let's go to play and we can see the LED is turned on. So whatever program we wrote in this Arduino IDE, now it's working in the Proteus simulation as we worked with AVR1. If we have any questions or doubts, we can ask. Otherwise, I'll go to the next one. Okay, so next one is, now I'm going to replace, not replace, I'm going to replace the coding, not the circuit one. So we turned it on. Now let's turn it off after a second. So simply I'm saying delay 1 second and digital write LED comma low. So delay of a second. After that, the LED is off. So now let's again export the compiled binary. We have this method also to compile, and we have this method also to compile. But currently we need the hex file to run the code. So we are not compiling with this, because if we compile with it, it creates the hex file in temporary folder. And to access the temporary folder after every change is quite very difficult. That is why I save the code in desktop, and whenever we click on export compiled binary, every time it creates the hex file in the same folder, that is the desktop one. So now let's again click on export compiled binary and let's go to this Proteus, and here we know the process. So we not need to do it again because we already have the location of the code and which is assigned to this Proteus earlier as well. So we not need to come here again and again. Simply what we have to do, we have to change the code. After changing the code, stop your circuit and play your circuit, the same which we did in AVR coding. So now we can see it's on, and after a second, it's off. Now, if we want to run this code for infinity period of time, if we want to run this code for infinity period of time, we have to put this code in a loop. So to put this code in loop, let's cut this part, LED high, LED low, and paste it to loop. Because I already told you, if we have to run the process for infinity period of time, then we have to put that code into void loop. Void setup is to run the code for only once. So I just pasted the code in void loop, and now let's again compile the code. And let's again compile the code. So here now we can see once it's done, the LED is going to turn on and turn off for infinity period of time. So let's wait for the compilation to be done, and then we will do that. Okay, one small error. I just cut the curly braces as well. Let's balance the braces. I was getting few messages from the students in the group that why we using this Proteus, we have other options as well like Tinkercad. So yeah, we have Tinkercad option available for the Arduino simulation. Even we have more simulation options available, but Proteus will give you more benefits because here we can import the library of many external peripherals, and a lot of other components are also available. We have many options available here. But in other simulations, like other simulators like Tinkercad or anything else, we do not have a lot of external peripherals available. That is why I always use this Proteus. And if you create your schematic and further if you want to convert that to a PCB, that option also is also available in Proteus. But the version which I am using is Proteus 7, so it does not allow the PCB designing. For PCB designing, we have another version which is Proteus 8 Professional. I have that version also installed in my PC. But for this purpose, I generally use Proteus 7 because it has the best UI. So now let's click play again.
Sir, I am also using this software last 2 years.
That's so nice. Very good.
Yes, sir. It's a very best software.
Yeah. Okay, so we have the code, and this time it's in a loop, LED high, LED low, with a delay of a second. So it must run the LED for infinity period of time. But when we go to play the circuit, the LED is continuously on. It's not even turning off. It's not even turning off. Although this is in loop. And why it's happening? Because this is happening because we said turn on the LED and hold for a second, but we didn't said turn off the LED and hold for seconds. So delay is not here. We need to write the delay. So let's write delay of 1 second and then compile it. Delay of a second and then compile it. Okay, so the Proteus and play. So now we can see the LED is turning on and turning off after every 1 second. And if we change the delay from 1000 to 100, that means every 100 milliseconds we have to turn on and turn off the LED. So it will do the process very fastly. Let's see the same thing. Let's wait for compilation. And let's play. So now it's turning on, turning off every one after every 100 milliseconds, not 1 second. Done. So now let's try to include more LEDs and let's change the code. So I'm going to delete this ground for now. And let's rotate this in anti-clockwise direction and let's drag it to here. Let's drag it to here. And now let's put more LEDs. That means I'm first rotating this 2, 3, and 4. Now let's connect the LED with 12th and then with 11th, then with 10th. And now let's connect 4 LEDs, D1, D2, and D3. And negative pin with ground. Let's come to coding part. So before setup, int LED1 equals to 13. LED2 equals to 12. LED3 equals to 11. And LED4 equals to 10. So as we have 4 LEDs, so we have defined 4 different variables for that. Now I'm going to define the pin mode for all the LEDs. So now we have declared all the 4 LEDs as output. Now suppose if we want to turn on all the LEDs and then after a second, if we want to turn off all the LEDs, we need to write the code for that. And how to write the code? Let's come to void loop, and here we are saying digital write LED1 comma high. As I said, we have to turn on all the LEDs at the same time. That means if we are turning on the second LED, then there should not be any delay between first and second. So we have to write the command just after this. We have to write the command just after this, which clearly means that both the lines are going to work together. Now, third also at the same time, so the delay is not required here again. And digital write LED4 comma high. So what we did, we turn on all the LEDs at the same time, and then after a second, we turn them off after for 1 second. So hold for a second to turn on all the LEDs, and hold for a second to turn off all the LEDs. And we are doing this process repeatedly. That means it will take 2 seconds to complete for very first time, and after that, it has to repeat the process for infinity period of time. So meanwhile, I'm saving the code and trying to run this on the circuit. If you have questions, doubts, ask me. Sometimes I feel like if you guys are not active in this then why we are doing these live sessions? I already have all those tutorials in recorded mode. You can ask the counseling team who are in the contact with you guys through WhatsApp. Just ask them; they'll give you the recorded one, and let's end this live sessions by the end of the day only. Because I have seen a lot of times no one even replies if I am asking anything from this side.
Sorry, sir, but due to poor internet connection, we are not active.
Due to poor internet connection, you are not active. This is your
Yes,
reason.
sir.
And what about others? Do all have the same reason?
No, sir.
Anyways, leave it. So now I have a new code.
But sir, I'm trying to giving my best.
Okay, thank you. So now I have a new code and the file is saved with the name PA2. The file is saved with the name PA2. So this time when we are going for simulation, when we browse the file, we have to change the location because earlier it was PA1. Now we have to change it to PA2. So let's double click and select the file and click play. So now we can see all four LEDs are turning on and after a second, all four LEDs are turning off. This process is happening for 2 seconds. And if we want to reduce the delay, we can make it 100 milliseconds for each task. So if we do so, we can in this screen of the circuit diagram of Proteus, we can see the LEDs are turning on and turning off very fastly. So let's wait for the code to compile. And after seeing the output of this program, we will go to the next one where we will try to turn them on one by one. It's working fine. So now let's go to the next one. And one by one mean, first of all, I'll take a new file. Let me copy the whole code of this file and paste it to this one. I'm not going to write each and everything again. That's why I did the same. And now we again have the same configuration of LEDs. We have a variable LED 113, LED 212, LED 311, LED 410. It's not mandatory to use the variable LED 1, 2, 3, 4. We can use any other variables as well, like A, B, C, D. So it's completely our choice what we want to use. Now, after this, we defined all the pins as output. Now let's come to loop where we have to write LED 1 comma high. And as I said, we have to turn them on one by one. So let's write a delay of a second here, delay of a second here. And when the 2 is on, after that, delay of a second again. And when 3 is on, then again delay of a second. And let's not write the delay of a second, otherwise we will have to wait for too much of time to complete the code. So I'm writing it 500 milliseconds this time. 500 milliseconds, that means 0.5 second. And after this, LED 4 is high. So first is high after 500 milliseconds, second is high, then third is high, and then fourth is high. So after this, we want to turn off all the LEDs one by one, starting in the decrement order. We came from 1 to 4. Now let's go 4 to 1. So that means first we have to turn off the 4, then 3, then 2, and then 1. And let's put the delay here. So I'm copying this line and pasting it to everywhere. And at last also we need a delay. So I just did it 500 milliseconds. And after this, it's going to repeat. That means the first LED on, second on, third on, fourth off, third off, second off, first off. Now let's save the code. And to save the code, this time I'm going to assign a new name. So it's PA3A3. And let's go to sketch and export compiled binary. Yes, we can use this method to make traffic light. Now let's stop and assign the address of a new code, which is PA3 this time, and select the hex file and again click play. So now we can see the LEDs are turning on one by one, D1, D2, D3, D4, and then D4 turning off, D3 turning off, D2 turning off, and D1. And the process goes on repeatedly for infinity period of time. Now we will do one last code and then you can try the traffic light. I'll give you a hint for that outside. This time we have to turn on only one LED at a time. What I mean to say, first LED is on, after that second is on. But what I want, when the second LED goes on, the first should go off. When third is on, then second should be off. And when fourth is on, the third should be off. So this program we did in two different ways. First, we turned on all the LEDs together and then turned off. Then second case, turning on the LEDs one by one, but not turning off the last one. Once all the LEDs are on, then we are turning them off one by one. Now next what? D1 on, after a second, D2 on, and at the same time, keep D1 off. And when D3 is on, keep D2 off. And when D4 is on, keep D3 off. And again, when D1 is on, keep D4 off. So we have to repeat this process for infinity period of time. So here, when we are turning on the second LED, we have to write the code for the first one, LED 1, comma, low. And now let me copy this line. And when 3 is on, let's do 2 off. And when 4 is on, let's do 3 off. And then when we are done. So let's delete the whole the rest of the code. The last line is LED 4 low because we turned it on last time. And after this delay, we are saying turn off the LED 4 and then turn on the LED 1. So these two lines are happening at the same time because there is no delay between these two lines. So if you want to write this line here, that's okay. And even if you want to write this line just after this, that is also okay. When loop is going to repeat, there is no delay between the fourth low and first high. So obviously they will work at the same time. So now let's run the code. Come to Proteus, stop the circuit and play the circuit. So now we can see at a time only one LED is on and the loop going on from D1 to D4. Now you can try many patterns like disco lights for Deepavali and other festivals, DJ lights, and a lot of more things related to this topic using many programs. Now I'll give you a small idea about how we can use the traffic light. So in traffic, we have red, yellow, green concept. And if we are going to create the traffic light program for 4 signals, then we need to take 4 red colored LED, 4 yellow color, and 4 green color LED. Or otherwise, we have a second option available in this Proteus. Simply go to pick and search traffic light. So we can see the traffic lights are already there. We not need to create the combo
Sir,
from our
I
side.
have a question about their pin. Sir, I have a question about their pin. Sir, can you please explain SDA and SDL pin?
You are in so hurry, I guess, asking about SD and SCL pin. See, basically, SD and SCL pins are the part of I2C communication. And this is not the topic for the day. We will do it in future. That time I can explain you because we have to do a lot of things before that, like Bluetooth communication, which is called serial communication. So we haven't understood about the serial
Okay.
com till now. So it's not easy to understand SD and SCL for now. Okay.
Okay, sir.
Yeah.
Okay.
So you can create the traffic light using these lights. Okay. And here we have 3 signals, red, yellow, green, and you can give the powers to them. let me show you this example just by giving them power through the power source, and later you can connect this with the programming. And now if I play, I can see red, yellow, green. So ground is also not required here because it's inbuilt in this traffic lights. That is it for the day. So now you can try many different patterns for your LEDs and traffic lights. And then we will start with a new topic tomorrow in next class. Thank you so much. Bye-bye.
Okay, bye, sir. Good night.
Good night.